Saxon Algebra 1, Lesson 41. Greetings, my students. We've returned from Thanksgiving. We're back on track. We are ready to dive into Lesson 41. Lesson 41 it sounds so harmless. We're going to start with adding like terms. And you're like, I know how to add like terms. That's really easy. But I'm going to throw a big mess at you. And we're going to figure it out. Copy with me, please. Okay. I'll breathe while you finish writing. But what I'm sure you'll agree, even if you haven't had time to finish writing this and actually think it through, this is a hot mess. There's no like terms in here. This looks ridiculous, doesn't it? But John is good and John is kind, and we're going to trust him to have created some nice like terms in here. We just have to clean things up. So we're going to go one term at a time and make sense of it. And the main thing we're going to do is we're going to change all the negative exponents positive, and we're going to combine any time we see the same base on the bottom and top, we're going to combine those. And remember, the way we do that is what's called the quotient rule, and if we see one on the top and one on the bottom, we subtract the exponents, and that will simplify it. So I look at this first term. Okay, let's just go one term at a time. The B is harmless. It's not going to sting us, right? Here's an X and here's an X. All right, we want to do this. So we see that X to the 1 over X to the third is going to equal X to the 1 minus 2 or X to the negative 2, right? That means it goes downstairs, right? Because we want to put that down because that's a negative exponent, so it flips it down back into the basement, back into the dungeon, okay? So that's how we simplify the X. That's a lot. The Y comes up because it's got a negative exponent, so we pop it up. All right, this one is all cleaned up. We can only pray that the other terms sort themselves out. Now this isn't a fraction, so I'm going to put it over a 1, and we'll see what happens. We're subtracting. The 3 is the only number in town, so he stays. The B stays. The Y looks good. There's no other Y's. And the X is negative, so it flips down. Look what happened. Look what happened. They match now. Oh, that's so satisfying. All right, let's see what happens down here. 4 stays the same. Notice I'm going alphabetically. B, X, Y. I went B, X, Y, B, X, Y. Now I'm going to do it again. B, X, Y. All right, number first. 4 is good. B needs to jump up. He's got a negative 1, so there's no value. It's just a 1, but I need to flip it. X belongs in the basement. He's doing fine, and the Y squared looks good. Now look what we've done. We've created 3 matching terms. You never would have guessed it, right? These all match. So now what we can do is just take the coefficients off each one. I put a 1 here to remind me, and it's the problem is as simple as 1 minus 3 plus 4. And that is 2, right? Because that's 5 minus 3 equals 2. So our answer is 2by squared over x squared. Yay! We have 2 more of these beasts. If only you were here to do them for me, so I could just sit down and you could write. Example 41.2. Okay. we're going to do the same thing. We're going to deal with negative exponents. Remember, x to the minus 2 equals 1 over x squared, right? To use a letter. So we flip to the other level of the fraction. So this a is the only a in town. It's going to go downstairs, a to the third. Now b, we're going to use our quotient rule. There's an invisible one there. So to use this format, it will be 1 minus 3. So that means our final value is 4. So b to the 4th goes right up there. Oh, okay. And look at the second part. It's perfect, it's clean, it's fine, there's nothing to change. And look what happens. It matches. Aha! So to combine them, we remember that there's an invisible one right there. We can add it anytime we want. And we get 3b to the 4th. Oh, sorry, I was looking at the wrong problem. Sometimes I glance over at the answer just to make sure. And sometimes I look at the wrong problem and then I'm like, what did I do? I'm so far off. I'm like, oh, never mind. That's the right answer for this one. Yay, okay? So these two principles, the quotient rule and our negative exponents, it's clearing up a lot of our mess, isn't it? Here's one more. Example 41.3. We've got 3 again. Three terms. Okay. I'm double checking while you write. Okay. So here we are. We're simplifying each term. Remember, we're looking for negative exponents that we can flip, and we're looking for any places where there's the same base above and below that we can simplify using the quotient rule. In this one, I see quite a few negative exponents, but I don't see any repeating bases, right? Within each fraction, there's only one A, one B, and one C. So let's go ahead and flip things around and see what we've got. 7. Now the A needs to go downstairs. The B is perfect, and the C needs to go upstairs. I flip it, and that takes care of the minus sign. I can write the 1 here if I want, but I don't need to do that if I don't want to. Okay, let's do the same thing here. 5, A looks good in the basement. B looks good up top. And C needs to flip up, and we can put the 1 if we want. These match. I'm excited, aren't you? But look at this one. There's nothing to change. That C won't go upstairs. I'm going to double check just to make sure that I wrote the problem correctly. Nope, that's right. So what we see, and John does this in the homework every now and then, these two will combine, but this one does not. It's so close, but it's not an exact match. The C would need to be in the numerator, not the denominator. So we can combine these two, and we get 2b squared c, right? 7 minus 5. Everything else stays the same. Plus 3b squared a cubed c. That's our answer. That's as good as it's going to get. Isn't that sad? I always feel sadly let down. But that is all we can do, is just combine the two and then tag the other one on at the end. So that's the way that works. This is our practice in these really crazy rational expressions where there's lots of things we can correct before we'll know for sure if they're like terms. So the first thing you do is fix the negative exponents And then the second thing that we did is we used the quotient rule to simplify any time there were the same bases above and below. And that's the one that looks like this. If you've got the same base above and below, you subtract, right? Cool. Okay, 2 more problems, new section, part B. They're called 2-step equations. Not like the Texas 2-step. Do you know if that is? It's a line dance. You probably think more of Texas Hold'em than Texas 2-step. But that's okay. I'm just diverting myself. All right, these problems are fun. I think you'll enjoy them. If x plus 3 equals 7, what is the value of, I'm not going to write all that out, x minus 8? So the first thing we do is we solve the equation. If x plus 3 is 7, all right, then that means we should be able to subtract 3 and find out that x equals 4. That's our first step. The second step is to use the value to solve the second part. Okay, now we know that x equals 4, and so then we can say 4 minus 8 equals minus 4, and that is the correct answer. Okay, second one. If, and I'm not going to write the words as much this time, if, because you don't have to, x minus 5 equals 7, then what is the value of x plus 4? I always do it with clear sides so I can see first step, second step. First step, I solve this, I add 5, x equals 12, that cancels, that cancels. Now I plug it in over here, 12 plus 4 equals 16. There's my second answer. Easy and fun, right? Especially compared to that hot mess we were doing in part A with those, all the crazy, messy things to fix. These are short and sweet, and I hope you have a lovely time doing them. I will see you soon for lesson 42. Bye.